When we were discussing the chemical potential of a component in an ideal gas mixture, we described the chemical potential using this equation. Right, where we had some reference chemical potential plus RT natural log of the partial pressure. All right, and so this is one way of writing the equation. But perhaps the more common way that you'll see, not only in the chemical engineering discipline, but in just the more general chemistry and physics way of describing thermodynamics, they write their chemical potential equations like this. Where rather than calling that first term a reference chemical potential, instead what they call it is a standard state chemical potential of the pure species, I. Okay? Alright, and so what I want to introduce in this video is just the terminology of what the standard state chemical potential is. And so when we talk about the standard state chemical potential, it's a chemical, or it's a term that specifies, it's similar to a reference condition, and it's going to specify these things. So it'll specify your state of matter, so whether the pure species, or whether your reference species is a solid, liquid, or vapor. It'll specify a pressure. So, for instance, you could say that your P naught, or your reference pressure, is like 1 bar or something. And it could also specify a concentration. Right? And so commonly, by that I mean the standard state could represent the pure species I, or sometimes you'll see it refer to dilute species, so where the mole fraction of the species in the mixture is very close to 0. Or sometimes, in some instances, they may use a more concentrated standard state. The thing that the standard state typically does not specify is temperature. And so commonly when people talk about a standard state, they have to mention that the standard state is going to change as a function of temperature. So they usually put it as a function of T. In any case, the reason I bring this up is because when we talk about dilute solutions, we're going to write the chemical potential in this format. So the chemical potential of our species as a function of T is going to be equal to the standard state chemical potential at some temperature and essentially reference pressure plus this RT ln of xi term. Okay? And so we'll use this format not only for the remainder of this chapter, but also in the next chapters when we start dealing with more concentrated solutions.